All right, hello. Today we are going to be starting our first set of guided notes. You guys should have your Frayer model worksheets in front of you. It has 8 different Frayer models. We're going to talk about how I want you to fill them out as you're watching this video. Our first lesson is going to focus on angles and lines. So we're going to go through this, and I already have some of the definitions written out. With you, we're going to be drawing the picture and talking about how it is named. So I would like you to write what is highlighted on the top is the title at the top of your page. We are all starting on page 1. So we are going to label this as our first page, page 1. Okay? And on the first line of our page, we will be able to define and identify key vocabulary and explore angles. Don't worry, as you're watching Edpuzzle, the Edpuzzle will pause because I want to give you time to write things down. When it pauses, follow the prompt and answer the question if there is a question to continue. Okay, so next, I want to show you what the Frayer model looks like. It is this one. What you see here on the top right, you're going to be writing the term. So like, let's say our first term is point, you would write the term point there, okay? Your definition, you're gonna pause and write it, and you're gonna copy the picture we do together. The only thing you are not gonna do during the video is the example and non-example. I'd like you to work on that after the video has been completed. So we're going to go ahead and get started. Again, we are not writing an example or non-example until after the video is completed, but this is our first word. Our first word is point. Okay, so a point is an exact location. In exact location, it could be in space, it could be on a flat surface. So if I drew a point inside this box and I named it A, we would call that, and I'm going to write something in quotes because that's me telling you that that's how we say it out loud. And it's good to have this note for ourselves. Writing something in quotes is how we say the term or the notation out loud. Point A. Again, Edpuzzle will pause. We'll continue. Next one is a line. So a line is a collection of points. Collection of points, that means we can have multiple points, many points, and it continues forever in both directions. So something that has many points and continues in both directions. Let's say I have point A here, which is on this line. What am I drawing at the end of this line? I am drawing 2 arrows. The arrows signify that it goes on in both directions. So let's say I have B, I could have another point C. This is our line. And because it has these 2 arrows, we know that it extends infinitely in both directions. All right. What if we have something that is part of a line? It has 2 endpoints. Then that is what we call a line segment. Okay, so if we go to our previous example, here we have a line. Can we identify a segment in this line? A segment would be AB. We can also have a segment BC. What's the last segment you can identify? I see the line segment AC. Okay, so we're gonna draw a quick a picture. What does that look like? It is a part of a line. So it has 2 endpoints. So let's say this is A and B. They're connected here. Gonna try and draw it a little straighter. That is a line segment. Now, we're going to talk about notation. That is what we call this line. This is line segment AB. Awesome. Okay. Next term we are looking at is the term ray. This is a specific type of term in geometry where we have something that starts at one point and it extends forever in the opposite direction. So it's different from a line segment because a line segment has two endpoints versus a ray has one endpoint and the other end, it continues forever and ever. So let's say we have our endpoint A, which I have not made a note, but this is an endpoint. And the rest of that line continues. This is an example of a ray. Now let's say we have point B here. I'm adding a second point so we can help write a name for this ray. Now similar and slightly different from the line segment, we do need 2 points to write our ray, our notation, and we're gonna draw our mini ray on top of those 2 letters. So this is ray AB. I'm gonna zoom in. It's a little small. I realize the last one might have been a little small. But again, this, I'm gonna highlight, is our endpoint A here. Okay, we've got an angle. An angle is formed when 2 rays share an endpoint. Okay, so let's imagine that. We have 2 different rays. Let's say I have my first ray, A, B, and let's say, no, let's not give them names. Let me do this. 2 different rays, right? Now, what if I take this one and I put it over that ray? Let's zoom in and see what I'm doing. 2 rays. Let's say I take this one and we put them over so they share an endpoint. They form an angle. So this is an angle. Now let's say that point that they share is point A. Well, we know we're going to have at least 2 points on a ray. So initially they started separately, right? Do you guys agree? We started a separate rays. So I'm going to say, let's say this is point B and this is point C. We're moving this back, right, to form an angle. Now, that point that they share, this pink point, we're going to call this point A. Now, how will we name this angle? It's going to need 3 letters. 3 letters. We're going to start not at the end point. We need to start at one of either point C or point B. Okay? So it's going to have a little angle symbol. And I'm going to go from left to right all the way. So C to A to B. All right, C to A. I'm trying to go, I'm mirrored right now. So C to A to B. C, A, B. This is called angle CAB. Okay. Now we have 2 more, 3 more, I believe. Now these are going into specific types of angles. Let's say we have a right angle. A right angle is exactly 90 degrees and it forms a perfect corner. Okay. So let's say, you have a sheet of paper. I'm trying to think. I don't think I have anything. Maybe this on my laptop. This forms a perfect corner here, right? Perfect corner. This is a 90-degree corner. So something that forms a 90 degrees, it's like 2 rays. Try and get it exact. I don't have a protractor. I don't have something to measure, but we are going to draw this little corner here, corner of a square. This symbol tells us that it measures 90 degrees. If we think we see a right angle, but it doesn't have that square corner, we cannot assume that it's a right angle. Because in geometry, sometimes things are, it's on the tip of my tongue, but sometimes we cannot assume if we do not have specific symbols sometimes. So right angle, this is an example here, forms a perfect corner. Now, a different type of angle, we're moving on to complementary angle. Now, a complementary is when we have two different angles that add up to 90 degrees. So let's say I have this angle here, this angle, two peace signs. And when you put them together, if they formed 90 degrees, they'd be complementary. So let's try and draw that out. I'm going to show you guys what that looks like. Let's say we know we want it to be 90 degrees. Now, if I cut this in half, right, we have angle 1 here, this pink one, angle 1, and we have angle 2 here. Those two angles, if I put the symbol here and I'm telling you guys it's 90 degrees, kind of want to make it a little here. There we go. Oh no, there we go. Okay, now if I'm telling you that this blue one and this purple one are two different angles, but we push them together and together they form 90 degrees, that is what we call a complementary angle. Okay, so again, two that form 90. All right, we are going on to our very last one, supplementary angles. Two angles that add up to 180 degrees. Now, let's go back to this one. A right angle is 90 degrees, correct? What if I have two right angles? One and then another one back to back. It'll form what on the bottom? It'll form a straight line. So two angles, I'm going to draw two diagrams. Two angles that form 180 degrees, right? Because 90 plus 90 is 180, are supplementary. Now, you might not see this exact example. So I'm going to go ahead and on this last one, I'm going to show you guys a example and non-example that we might draw. Okay, so let's say we have a straight line because we know a straight line sums up to 180 degrees. Now let's say we have one angle that measures, well, what's something that when you add, it gives you 180? What if this is 130? And we're going to talk about why I know this one is 130 on the next time we have a lesson. But let's say this is 130. How many more do I need? What does this angle need to be to get it to 180? So I'm going to do 180 minus 130. And if this is 50 degrees and that other angle is 130 degrees, 50 plus 130, it gives us 180. Awesome. Now, a non-example, I'm going to go with something that is not 180. I'm going to go with, let's use our complementary example. If this is 90 degrees, it is complementary, not supplementary. Not supplementary. So an example and a non-example that you guys can use. Um, Again, for the other ones, you're working on it at the end of the video. We have reviewed a few different terms. You can pause here if you want to read through what you should have for your definitions. And again, it's your turn to practice these skills. You need to complete the Freyer model, and I'd like you to work on practice 1.1 due at the start of our next class period. Bye. Okay, I'll see you guys during our next class.